Yeah, hello. I'm going to tape the lecture here. I apologize for missing the class yesterday. I'm beginning to feel better. I'm starting to feel better today. Certainly better than I have been. I'm still a bit. I'm not 100%, but I'm beginning to get there. So again, I apologize for not being able to make it yesterday. But what I'm going to do here is tape the lecture, and I'm going to tape it, and I'll post it on my YouTube channel. I'd like to have you watch this lecture before the next scheduled lecture next Thursday. I won't give you any assignments on this lecture this week, but I will give you an assignment on this lecture after the class next week. You will get an assignment sometime tomorrow. That's Saturday, the 28th. So you will have an assignment there. We're going to talk today about oligopoly and externalities. At the end of the class last time, I was beginning to introduce models on oligopolies. Just getting started on that, so I decided to stop there. So we'll go there. We'll begin with that, and we're going to go through three examples of oligopoly models, and mathematically and graphically modeling oligopolistic behavior. We're going to look at the behavior between two firms. That's the easiest type of, the smallest type of oligopoly is a two-firm oligopoly, which is what we call a duopoly. A duopoly is a market with two firms. We're going to look at the behavior of two firms, and in all of these cases, we're going to be talking about a first firm. It's going to be games. These models are all the form of games, very similar to the forms that you've already seen. And in fact, some of the outcomes, some of the approaches are quite similar to the models that I've presented. These are well-known models. These are models that I've taken from the literature. So these are models that are well known in the literature. They're representative. They're what we call representative models. There are a lot of different kinds of models for oligopoly, and models come into favor and go out of favor. So these models may or may not be currently fashionable. There's certainly fashions in economics as well as in any other discipline. And so keep that in mind. You may encounter examples of these models in your studies and in the economics literature going forward. So and keep that in mind as well. And we'll begin with the Cournot duopoly model. It's an oligopoly model. Cournot, Antoine Augustin Cournot, he was a French mathematician from the 19th century who made significant contributions to the field of economics, and he's pictured there. He's credited with being the first person to use mathematics to study supply and demand, and the first person to draw supply and demand curves on graphs. He was very interested in the use of mathematics in economics, and is considered to have brought a lot of rigor to the field of economics. A very, very early and very disciplined. He brought a very disciplined approach, and this was early in the 19th century. And in fact, he is best known even today. And this is the model we're going to present here. Is often used today to look at the behavior between two firms. And this model is known as the Cournot duopoly model, and he developed that in 1838. So we're talking now, this is a model that's approaching 200 years old, and yet it can still tell us something about the way that firms behave. So in this model, in Cournot's duopoly model, there are two firms. We'll call them firm 1 and firm 2. And using his example, the two firms bottle natural spring water, and they sell the water in a local market. So this example, he developed this example because it was an example where the firms essentially had zero marginal cost beyond your fixed cost. You drill a well to get to the spring water. Once you drill the well, then you pump the water out, essentially, and you bottle it. So it's essentially an item. It's a very simple item that has essentially a marginal cost of production that's close to zero. The main cost is just the fixed cost of entering the market. So the firms play a competitive game, and it's very similar to the kinds of games that we've seen before in game theory models. And this is a competitive game with the following features and rules. As I said, the firms produce the spring water at zero marginal cost. The second is that market demand for the spring water is linear and is downward sloping. In other words, the firms have market power. Each firm has market power since they face a downward sloping demand curve. So that's a very, very important assumption. The firms maximize profits, a very standard assumption. The firms move in sequence, with firm 1 moving first, not surprising. Firm 1 therefore acts as a monopolist in round 1, and we've seen that before in our natural monopoly model. The firm, it'll be the first in the market, it'll look around, there's no other firm, so it'll act as a monopolist and price accordingly. And then firm 2 reacts to firm 1's move in round 2 and maximizes its profit from the remainder of the market not served by firm 1. Then firm 1 reacts to firm 2's move and maximizes its profit from the remainder of the market not served by firm 2. So this moves back and forth in sequence until an equilibrium is reached. So this is a game where, just like before, there's approaching some type of equilibrium. And in this case, we're going to see the movement of the two firms in response to each other's firm, or the moves of each other's that each firm the firm that's their competitor makes. It's important here to note that the firms do not anticipate the response by the other firm. So this is a little bit different model. This is a difference from that and the natural monopoly model that I presented to you earlier. This model, the firms do not anticipate the move of the other firm, and we'll see that this will produce a different kind of outcome. And in fact, we're going to get to what looks like a similar position to where we were with the natural monopoly model, but in this case, we'll see a very different outcome as a result of this competition. And also, I think here this model basically has a zero fixed cost. So he's also assuming a zero fixed cost and a zero marginal cost of production. Let me just make sure about that. Yes, that's right. If the fixed cost is zero, so that's an important point here, and that's why we don't end up with a natural monopoly situation. Is because the firms produce the water at zero, with both zero fixed cost and zero marginal cost. So the graph shows the outcome for firm 1 in round 1, and for the Cournot duopoly model. And here, so firm 1 is the first firm to enter the market. So firm 1 acts as a monopolist and makes a monopolist profit maximizing decision. That is, it sets its marginal cost equals marginal revenue, and it maximizes profits at the point the price equals 20, P1, price in round 1 equals 20. The quantity produced by firm 1 in round 1, that's Q11, is also 20. And so you'll note that that profit maximum result is the same as that shown in round 1 of the natural monopoly game on page 48. And we've used the same demand function here, so we get the same outcome. The only difference here in the outcome is that the average total cost equals the marginal cost, which is 0. And so as a result of that, because we have a marginal cost of 0 and a fixed cost of 0, you can see here on the profit for firm 1 in round 1 is the entire revenue, which is 20 units times the price of 20 equals 400 units. So the profit here is 400 units. And remember here, this is the green line shows the marginal revenue curve for firm 1 in round 1, and crossing the axis at 20, and so that is the outcome, or the output of the firm is where marginal cost equals marginal revenue equals 0 is the output of 20 and produces a price of 20. Now we're going to just go over this result and derive it mathematically so that you can understand this clearly. It's always helpful to look at the mathematical derivation of that so we understand mathematically where our result comes from. So the two firms in the market face the following industry demand curve. The price for firm in round N is and this is the initial price, I'm looking at this. I realize that is the price of round. That should be P1 equals 40 minus the quantity for firm 1 in round 1. They have the total market. So that is the market price in round 1, and the QTN represents the total quantity of output produced by this would be by the two firms. It's really firm 1 in round 1. Now we've noted here the fixed cost to enter the market is 0. They face the same marginal cost. So the profit function for firm 1 in round 1, they face this demand curve of 40 minus Q11 equals P1. So the profit function, that is that's the price equals that is the demand curve. So it's price times the quantity is price times quantity equals the revenue. So price times quantity, since price equals to this, so that's 40 minus Q11, and the quantity in round 1 is Q11. So we multiply that by Q11, and that's our profit. We minus the 0. It's a marginal cost of 0 to produce the good, and a fixed cost of 0 to enter the market. So that's firm 1's profit in round 1, and that works out to 40 times Q11 minus Q11 squared minus 0. So that's the firm's profit function. Then the firm calculates its profit maximizing output and its profit maximizing price by taking the first derivative of this profit function. So the first derivative, and we set that equal to 0, will tell us mathematically what that outcome is. So the first derivative tells us how the profit changes. If you have not had calculus yet, what we're looking at is how does the profit change with the change in the output of the quantity of the good produced. So we take the profit function, and the first derivative, we calculate the first derivative of that profit function, that which tells us the change in the profit with the change in the quantity of output, and then we look at that. We set it equal to 0. That is, if you're going to have a curve, it's a curve that's going to go that's going to look like that. We set it equal to 0. That's the slope is equal to 0. So that, and solve, so we get that with the first derivative is 40 minus 2 times Q11. So we set that above result equal to 0 and solve for Q11, which produces the profit maximizing output. So that's 40 minus 2 times Q11. We set that equal to 0. So 2 times Q11 equals to 40. Divide each side by 2. Q11 equals 20. And there we show it there. Q11 equals 20. So since Q11 equals 40 minus P1, since Q11 equals 40 minus P1, we take that initial function, Q11 equals, move that over, 40 minus P11. Then we substitute 20, where Q11 is 20, then the price. The price is, that's P1 equals 40 minus 20. You can just do the math yourself. I think that'll help. Just do that on using pen and paper, just to confirm this to yourself. I think that's always useful to do when you look at this, to do this, work this out for yourself, so you know you understand this. So we can solve for the profit maximizing P1, and that's P1 equals 20. And we can see Q11 equals 20, P1 equals 20, and that in fact is our result that we show right there in the graph right there. So now firm 2 enters the market. Now firm 2, we see that firm, as we had with the natural monopoly model, firm 2 has a different situation. Firm 2 only has this demand curve. The remaining is left with the remaining demand curve. So, and in the same way as we had with our game in the natural monopoly game. So the demand curve facing firm 2 in round 2 is P2 equals 20 minus Q22. And you can just calculate that very easily. Just substitute the value 20 for the value 40. Put 20 minus Q22 and Q22 and 20, and you'll get Q22 equals 10. And P2 equals to 10, and that result is shown right here. Now, it's important to note that firm 1's profit maximizing choice was to take half the market in round 1, while firm 2's profit maximizing choice was to take half the remaining market in round 2. That's just a function of the kind of demand curve that we're using, and the fact that we have zero marginal cost. But this is the outcome that this kind of demand produces. So let me look at okay. Now the following demand curve in round 3, and this is also different from the model that we're because now what happens here is that firm 1 has to respond, and they don't respond by dropping their price. They now look, in this model, they now look at the remaining market. The remaining market is the 30. So now there is 30 left. So this is a little bit different game. It's a little bit different game than the one we saw with the natural monopoly model that I presented to you. So this is a little bit different game. So keep that in mind. The rules are a little bit different here. And that's the important thing here, is that when you look at games, the rules matter. And in this game, now the firm, instead of dropping its price to that immediately in order to keep its market, what its profit maximizing choice it now considers the entire remaining market, which are the 30 units. So that this firm now faces 30 units, and they start all over again. And so there's and also also here here the firms can charge they can charge a different price. So here the firm this firm is charging you'll see that they're producing a higher price. A higher price they produce, so their profit maximizing output is to get half the remaining market, which is 15, at a price of 15. So it's higher than the price that firm that firm 2 faces, that firm 2 had in as a result of its output, or in when it entered the market. So now firm 1's output in round 3 is 15. The price in round 3 is 15. So that price has moved up. Here we're saying when the people decide to buy the product in that round, they decide to go to they're willing to go to that firm. So again, there's a little bit different behavior on the part of the part of consumers as well. Is that we're assuming that that each of the firms have a monopoly in the moment. Basically, what we're saying here is that the firms have a monopoly in the moment that they face of the remaining market, so that they can price the remaining market and set that equal to at a profit maximizing price. So what happens here is the price in round 3 is 15, which is lower for firm 1, and then so now firm 2, because the firm 1 has got 15 as a quantity of 15, then the remaining market is 40 minus 15 is 25 for in round 4 for firm 2. So it's 25 minus Q24. Now what we can see is the firm then takes half the market, and so they're going to take half the market again. It's going to be 12 and a half. And what you can see is that they've raised their price, reduced their output. Firm 1 has reduced its output and raised its and lowered its price from the initial position because of they faced the remaining market. It's a little bit complicated. Now I'm looking at this. It might seem a little bit complicated. So if I don't have time here, I'm going to spend 90 minutes on this lecture. I don't want to spend any more time than that. I'm going to give you a 90-minute lecture just as if we were in class. But if I don't get a chance to go through this in the 90 minutes here, I'll talk a little bit about this at the beginning of the class next time, just to make sure that people aren't confused by this. But at any rate, here is the firm 2 in the demand in round 4. They have 25. The remaining market now is 25. They maximize. Excuse me. I still have a little bit of this cold. They maximize their profits, half the market, 12.5. Then the remaining market for firm 1 in round 5 is 27.5. They take half the market, 13.75, and you can see that essentially what's happening is that throughout market 1's market share is falling, while market 2's market share is rising. And again, the reason why this is happening is because in this game, we do not anticipate, the firms do not anticipate the move of the other. So what happens is they make a move, they see what the other firm, or then the other firm makes a move. The first firm is surprised. Oh, you made that move? Well, now I have the rest of the market. Well, what's my best move? I don't know what you're going to do, so I'll make my move. And then the other firm says, oh, I didn't know you were going to do that. Well, now this is the situation I face. And they keep on playing that kind of a game. As I say, it's a different game. So it's based on the amount and the kind of information that the firms have. So firm 1's market share is falling while firm 2's market share is rising. So we keep on playing this game an infinite number of times. This is an infinite number of times to produce the following outcome. Each firm has an equal market share of 1/3. The price of they each produce 13 1/3 units of the good, and for a price of 13 1/3, and each of them earns a profit of 177.7777 units. You can find the discussion on this game right there on the internet. If you want more detail, if you're interested in more detail on this, then please check that for further explanation. So that's the outcome for the Cournot duopoly model, is that the two firms end up with 1/3 market share, and they earn a profit of a profit of 177 units. So now what we're going to do is we're going to look at the Chamberlain duopoly model. The Chamberlain duopoly model is of interest because it's going to look a bit more. It's going to bit like the. It's going to be the two firms. The difference between that and the Cournot game is that the two firms know the impact of their move on the other firm. So that's the game that Chamberlain had here. And I just want to go a little bit about that. He was an American economist who made significant contributions in the study of monopolistic competition. And it is interesting to note that his work on monopolistic competition was an important influence on the work of the 2008 Nobel Prize winner Paul Krugman. He had an influence on that Nobel Prize winner. The Chamberlain model is similar to the Cournot duopoly model in that the two firms produce the good at zero marginal cost. The market demand for the good is linear and downward sloping, the same. So each firm has some market power. The firms maximize profits, exactly the same. The firms move in sequence, with firm 1 moving first. Firm 1 therefore acts as a monopolist in round 1. Again, exactly the same situation. Firm 2 reacts to firm 1's move and maximizes its profit from the remainder of the market not served by firm 1. So the first two rounds, it's exactly the same as the Cournot model, and exactly the same as in terms of movement and strategy as in the natural monopoly model that we looked at earlier in this class. But now what's different about this game is that firm 1 realizes after round 2 that the two firms affect each other, that the move that they make affects the other firm, and then firm 1's action is to produce half of the original monopoly output at the original monopoly price, and give the opportunity for firm 2 to share the market equally. So this is a game. This is a game where the firm anticipates the move of the other firm, and we'll see it produces a very different outcome. Now, it's interesting to note here, this is not a cooperative game. The firms are not cooperating, but they're moving with the knowledge of each other. In this sense, this game is more realistic of real oligopoly behavior than is the Cournot model, because the Cournot model, the firms don't know what the other firm is going to move. Now, you've seen looked at real world examples. You've looked at I introduced in real markets in Japan in the last lecture, and I looked at market shares for a number of industries of real firms in real markets. The important thing to remember is that in real markets and in oligopolies in the real world is that firms do know what other firms do. They know what other firms do, they watch other firms, and they react to them. So in this sense, the Chamberlain duopoly model is a more realistic model that tells us a little bit more about how the real world works. So now what we'll do, since this is exactly the same as the Cournot duopoly model until round 3, we're going to begin our analysis of this game in round 3. So here is the situation facing firm 1 in round 3. Firm 1 knows that the movement of the other or how the other firm will respond to its move. So now, as we recall, here was the choice, just as in the Cournot model. Here in the Chamberlain model, we have the same demand function. This 40 minus P1 equals 40 minus Q11. That's the initial market demand. We saw that the outcome was 20 for firm 1 that produced 20 at a price of 20. Firm 2 then only had the remaining market of 10 units and then produced 10 units of the good from 20 to 30, produced 10 units of the good at a price of 10. So its profit is 100. So a lot less profit, but it's earning profit. Now, firm 2 says, well, let's see. Here's the Cournot model. If I move in round 3 as if I don't know how firm 1 is going to react. In other words, if I maximize my profits based on the remainder of the market, which in this case 30 units are left. So I'm just as in the Cournot model. So if I maximize based on that and assuming there's no reaction by firm 2, then I'm going to take half the remaining market of 30 and produce 15 at a price of 20, and then the two firms are going to move, and they're going to have a profit each of 177.77. So now the important thing to remember here is that here is that firm 1 earns 400 profit in round 1. In round 2, if they do the 15, if they price and sell 15 at a price of 15, they'll earn a profit in round 3, the profit for firm 1 in round 3 of 225. The problem is that firm 1 realizes that's only temporary, and they know that if they play that game, then they'll get a profit of 177.777. And but they realize, here's what they realize. They think, okay, well, wait a minute. If I play this Cournot game, if I keep on playing this Cournot game as if I don't know what the other firm will do, then I'm going to end up with a profit 177.777. That's okay. I don't mind doing that. But can I do better? So let's think about this. Can firm 1 do better? Well, there's a total profit. They have a total profit of 400. They have a total profit of 400. If they play the Cournot game, they only end up with a profit of 177.77. So then they think, well, wait a minute. The Cournot outcome is 177 plus 177 is 355.55555. You add this to 355.555. So that's the total profit. It's 355.5555555. Firm 1 has already earned a profit of 400 in round 1. So they're thinking, well, if I can figure out how to keep the price at 20, if I can figure out how to keep the price the price at 20, then I've got the other firm. Well, and somehow we can divide the profit. I can potentially, if I get half the market at a price or more at a price at that price, then I can do better. There's more money to be made at this price, and there's more of a pie to share than if I try to play this Cournot game. So that's what firm 1 does in round 3. So that if firm 1 sets its price in round 4 at the original monopoly price, what market share of the original monopoly output of Q1 equals 20 can firm 1 leave to firm 2, so that firm 2 would rather produce their output at the same price rather than play the Cournot game. And that minimum, the answer is that firm 1 can set its market price in round 3 equal to the original monopoly price, so that they don't change their output, but set their output so that they leave some profit for firm 2. Here's the profit of firm 1 in round. That's in round 1 for firm 1. You divide it by 2. So if they divide it by 2, they'll have a profit of 200. And firm 1 will, and then firm 2 will say, well, let's see. If I play the Cournot game, and I have 30 remaining, so firm 1 will say, well, I'll produce 10, but I'll sell it at 20. I'll just sell it at 20. The market is willing to pay 20. Or is willing to pay me 20 if I produce only 10, and I'll earn a profit of 200. So firm 2 will say, well, let's see, if I do the Cournot, there's 30 left. If I maximize my profits based on taking half the market, then I'm going to sell my product for a price of 15, but then I'm going to move towards some type of Cournot outcome. And that's 177. But so I've got a potential of 200 as well. So then firm 2 will say, well, I'll take half the market too, and I'll earn a profit of 200. That's better. If I set my price equals to 20, I'll take half the remaining market, and now I'll get a profit of 200. Well, that's better than the Cournot outcome. So I'll take that outcome. I will take that outcome over the Cournot outcome. So the two, even though the two firms have not colluded, the two firms have not worked together, but by taking this action, produce an outcome where they're sharing the market. They're sharing the market, and they're both taking 1/4, 25% of the market, but earning a higher profit. So they'll take 50% share of the market that's priced at the monopoly price. This is also a very interesting thing, is that even though this is a competitive market, they're both competing, but they produce their output. What's interesting about this model is that the outcome is that they produce their output at a monopoly price. So the price is a monopoly price, even though the two firms compete. So you can have a situation where you have some type of competition. There is competition, but it can produce a monopoly price outcome, a monopoly price outcome, and a monopoly output outcome. So that's the very interesting result here, and it produces an equilibrium since neither firm has an incentive to move from their position. So each firm is making a profit of 200, and so neither firm has an incentive to move. Now, also, it's very important to remember the firm one could take more than half the market. They could take a profit up to, say, this profit level of 177. They could take, say, 220. If they took 220, so say they sold at 20, they produced 12 units and took 60% of the market. Well, they would still leave 40% of the market to firm one. That would leave 8 units, 8 at 20. Let's see, hold it. I'm sorry, they would 11. If they produce 11 units at a price of 120, then they would leave 9 units at a price of 20 to firm 2, and that would be a profit of 9 times 20 is 180. So actually firm 1 could take a little bit more than half the market in this game, and still firm 2 would have an incentive to play that game rather than the Cournot game. At any rate, this is an equilibrium, since once the firms get into this situation, neither firm would have an incentive to move from that position. This is what's called a Nash equilibrium. We've talked about the Nash equilibrium earlier. That simply means that the two firms have gotten to a situation where they do not have an incentive to move from the position that they've achieved. And I think that's I think that's a very interesting model, because it's a competitive model. The two firms are competing, they're acting in a competitive way, and yet and they're not colluding. They're not engaging in collusion. There's no illegal behavior, and yet at the same time, we end up with a monopoly price and a monopoly output, and the two firms share the market, so that both firms are better off than if they compete in a Cournot type market. Now we're going to move to another type of market, and this is we talked about where there's you'll recall from my lecture the last time I talked about that you can have a type of oligopoly market where one firm is very dominant, where one firm has a very high market share, and the other firm, there's other smaller firms. This is going to be similar to that, except that there's going to be a dominant firm and then a number of firms that do not have market power. So it's not quite the same kind of, it's not quite an oligopoly, but it's not a monopoly, and it's not an it's a little bit in between. So we'll call this an oligopoly, and we're going to look at that kind of behavior where you have a leader firm. So it's a little bit different. I'm still calling it an oligopoly model. It's not quite the same, but what we're going to do is we're going to see kind of a similar kind of behavior. We are going to see a similar kind of behavior where a firm has market power. They take a fair amount of the market, but not everything. And that's going to be the outcome here. And in fact, it's going to be an oligopoly. It is the outcome will be similar to an oligopoly in that there will be a monopoly price, that the follower firms will price their product at a monopoly, at an outcome that is based on the monopoly choice of the dominant firm. So it's not a perfectly competitive outcome. These small firms will be like perfect competition in that they're small and they don't have market power, and yet their behavior will be that they will set their price equal to the monopoly price of the leader firm. So in that sense, we are producing an outcome that looks like an oligopoly in a market that's not quite an oligopoly. So keep that in mind here and in this model. When I say price leader, you have a leader firm that sets the tone of the market, and the other firms follow. This is a very common thing that we see in markets where one firm has a dominant position. If one firm has a dominant position, then typically what the other firms do is they watch what the dominant firm does and follows their behavior, and that affects their behavior, and they follow. They follow what the leader firm does. So that's the most important assumption we make here, is that the one firm, the leader firm, has market power. The remaining follower firms are assumed to be output market price takers. Okay, so they're price takers. So just like in a perfect competition, they are price takers in their output market. But what's interesting here is that we have a firm that's dominant and will act in some kind of dominant monopolistic market behavior. So in this, and also what will be different about this model, is that the leader firm produces the good at zero marginal cost. So now it's important to remember here that we make that just so that our outcome is simpler, but it's not necessary. We could have a positive marginal cost, and that would not. We would still get a similar outcome. But I'm just doing this in order to keep the model simple. The follower firms produce the good at a positive marginal cost that increases in output level. That is, the follower firms face an upward sloping marginal cost curve. So here, this is something that we see that in the total market, that the total as the follower firms collectively together produce more output, they produce their total cost of production goes up. So they have an upward sloping marginal cost curve. The total market demand for the good is linear and is downward sloping. So the total market demand for the good is linear and is market sloping. But it's downward sloping for the total market, but it's not downward sloping for the follower firms. So in that sense, the follower firms face a price that is they're price takers in the market. They look, and the price here is set by the leading firm. So this is an interesting model where you can have an output that can look like a real world outcome. So here, the leader firm observes the sum of the marginal cost curves across all of the follower firms. So the leader firm can see what's going on in the market. The leader firm has market power, and they can also see the behavior of the follower firms. The follower firms, whether they can see the behavior or not of the leader firms, cannot have any impact on their prices, on the price of their output. So they face a horizontal demand curve, but there is a downward sloping demand curve that the total market faces. So what's going to happen here is the leader firm then calculates the remaining demand curve over which the firm can act as a monopolist and maximizes profits based on this knowledge. So what the leader firm does is the leader firm looks at the marginal cost curve, the total market marginal cost curve of its competitor firms that don't have market power. So it can see that, and it says, "Oh, okay, I can see what they're going to do, how they would react." Essentially, the firm one can see how the follower firms will react to its leadership. So it knows how the other firms will react. So then, since it knows how the other firms will react, then the firm one calculates the remaining demand curve over which the firm can act as a monopolist and maximizes its profits based on this knowledge. And so then in this game, the follower firms then choose the same monopoly price as the leader firms, since they're price takers. And this model will produce a result. The result is an outcome in the model where firms with no market power can earn above normal profits. So in that sense, the outcome looks like an oligopoly. It's not, as I said earlier, it's not quite an oligopoly in that the follower firms are small firms and they don't have market power, but we produce an outcome that looks like in an oligopoly, where the follower firms can earn above normal profits. So this is an interesting outcome where the follower firms earn above normal profits, but and at the same time that they don't have market power. That's probably seemed very complicated to you. I think it'll be a good idea for you to go back and after we go over this model, go back and watch this part of the video again. I think this will be very helpful because it begins to make more sense. It's a little bit complicated at first. Don't expect you to understand this at first, but this does produce a very interesting outcome, and the thinking that goes on here is very important. So keep that in mind. Now we're going to look at the outcome based on this. And now here it says exercise question 18. Please explain why this is the case. I'm going to leave that till later. Ignore that right now. Don't worry about that. I just noticed this. I didn't realize that was the case. But I'll change that when you get this the lecture notes in by email. So here is the before the start of the game, the slope, this is the demand curve in the market and the demand curve that the leader faces. This is what the leader can see. So the leader firm can see that there's a downward sloping demand curve, market to industry demand curve. So they can see that, and they can also see that their competitors have an upward sloping marginal cost curve, so that the more that they produce, the more the higher their price. So they can see that as well. So they can see those things. And now here we're assuming that the leader firm produces at a zero marginal cost. Okay. So now, what this says is the marginal costs represent the important thing to remember is that the marginal cost curve, and we talked about this last semester, a marginal cost curve represents the willingness of firms to produce a level of output at a given price. So the marginal cost curve is in effect a supply curve. This is in effect the supply curve of the follower firms. This is what their follower firms are willing to produce. So, for example, here I show this point here, the point A, px equals 6, qx equals 6. So the firms are willing. This says, this marginal cost curve here says, so that the firms are at a price of 6 are willing to produce an outcome of 6. So if the firms, the follower firms, see that the market price is 6, of the leader firm is 6, the followers are willing to produce 6 units of the good at that price. So in that sense, again, the marginal cost curve, the upward sloping marginal cost curve represents, in effect, the supply curve, the total supply curve of the follower firms. So if there was perfect competition, let's say that there was perfect competition, let's say that there was, the competitive firms are willing to produce to the point where they earn zero economic profit. Now we can see there that if that point is here, the 2020, at a price of 20, and an output of 20. So at that price, the demand is 20, and the price they're willing to pay is 20. So at that price, the marginal cost of production is 20. The price is 20. So those firms that earn zero profit, zero economic profit, and that is the perfectly competitive outcome. So if all of the firms were perfectly competitive, the total output of all the firms in the market would be 20, and the market price would be 20. So a price of 20. So a price of 20 in this case, if the firms are perfectly competitive, that would be the outcome. So what's also interesting here is that would be a perfectly competitive outcome. And what we're going to see is an outcome where the market price here it is actually less than 20. And so here the leading firm has market power if the price of the good is less than 20. Now that may seem very hard to understand at first. You're probably looking at this and saying, what do you mean? How can the firm have market power if they reduce their price? They have more market power. Well, that's what makes this model very interesting, because that here the leading firm has more market power if the price of the good is less than 20. So I'll explain why, and it's important to understand why. If the price of the good is less than 20, the firms are willing to produce. What are they willing to produce? They're willing to produce less than 20. So if the leading firm, because they have market power, they can set their price. Remember, that's what market power means. A firm can set their price. They can set their price, and they base they maximize profit based on their ability to control their quantity and the quantity of output and their price. So if the leader firm sets its market price at less than 20, the follower firms would be willing to produce an outcome that's less than the perfectly competitive outcome. Let's say, for example, that firm 1 sets a price of 18. They set a price of 18. The follower firms are willing to produce 18 units at a price of at a price of 18. So that means that the leader firm can produce up to 2 at a price of 18, can produce up to 2 units, at a monopolistic price. So they effectively have a monopoly. If the price is 18, then they have a monopoly over 2 units of output. If the price is 16, they have, if they have a price of 16, wait a minute, I'm sorry. So let me take that back. This is what's interesting. It's not 2, it's 4. Because if they set a price at 18, then the market is willing to purchase 4 units of the good. So this is an important thing to remember. And these are the kinds of things, the very interesting outcomes that are produced in these kinds of models that begin, they're outcomes that are very different from the perfectly competitive market for models that are fairly simple and yet can tell us a lot about the way that the real world works. Let's look at this again carefully. Right there, if the firm sets a price of 18, if the leader firm sets a price of 18, the follower firms are willing to produce 18 units of the good because their marginal cost here, this is the upward sloping supply curve. At a price of 18, they're willing to produce 18 units, but the market demands 22 units. See, here's the market demand there. At a price of 18 is 22. So the difference between 22 and 18 is 4 units of output. So at 4 units of output, the leading firm has market power. They have market power over 4 units. Let's say the leading firm sets a price of 16. If they set a price of 16, the follower firms are willing to produce 16 units of the good. They're willing to produce 16 units of the good at a price of 16. Well, then the total market demand then is 24. So 24 minus 16 is 8. So now the leading firm would have market power over 8 units. Again, we come down here. If the price is 14, excuse me, the leading firms are willing to produce 14 units. The market is willing to buy 26. The firm has market power over 12 units. So now you can see that, interestingly, the lower the price, the more market power. Fascinating model. I really like this model because it produces a very different outcome, and yet there's something that can be realistic about it. And what's interesting, the firm has monopoly power at a market price that's lower than the perfectly competitive price. If all of the firms were, if the firms had an upward sloping marginal cost and an upward sloping supply curve in a perfectly competitive situation. Very interesting outcome. So, if we take the point, so at this price of 20, so we've said that the leading firm has market power at the price below 20. At a price of 20, the leading firm has no market power. So the leading firm has no market power because at this price, the follower firms are willing to produce all of the output. They're just willing to produce all of the output. So at a price of 20, so at that price, they would be willing to produce that. The firm would have the leading firm would have no market power at that price. So now, so what we can see is that the leading firm will want to lower its price to the point where the amount of the market where it has market power is such that it can maximize it has monopoly power over that range, and it can maximize its profit. Now let's look at this point. This point at a price of 0, that's the follower. So at a price of 0 and QX equals 40, there's a demand of 40. The follower firms are willing to produce nothing at that price. So if the market price is zero, if at a market price of zero, the follower firms would be willing to produce nothing. The leader firm would be willing to produce at that price, and they would have total market power over the entire market. They would have monopoly power, but at a price of zero. So they certainly would have no incentive. They would get no profit. They would produce there. They would get no profit. They could sell 40 units of the good at zero price, so they would have no profit here. So what we have, this price of 20, then, is the lowest price that it's the highest price that the leading firm can face and have zero market power. So if it sets a price below that, it has market power. So we can, and now look at this price at 40. At this price, at a price of zero, the firm has complete market power, so they have complete market power. If they set the price at zero, then they would have complete control over the market. The follower firms would be willing to produce nothing. So between this point of 20, which is the lowest price, is the highest price that the firm can produce without where the follower firms are and above this price, the firm would have no market power. Below this price, the firm has market power. So between this point and this point, the line between this point is the demand curve along which the leading firm can act as a monopolist. That's the very interesting outcome here, is that this point from the demand curve, from here to here, is the point over which the firm can act as a monopolist. Since if it prices at that point, it would have some market power. Again, if it prices above 20, it has no market power. Below 20, it has market power. So this is its monopolist demand curve, and that is called the residual demand curve. That's the leftover. Residual means what is left over, and we'll see here that is the residual demand curve going from this point down to that point. So that this point to that point, that's the residual demand curve. That's the demand curve. If the leader firm operates along this demand curve, then it has market power. It can act as a monopolist over that demand curve. So it can set its price. And notice how this residual demand curve lies below the market demand curve. Since the market is willing to consume it, and remember that here's an important thing to remember, is that the demand curve, everything to the left of the demand curve is what the market is willing to consume at any price. So let's say the price is 22, and let's say the firm sets a price of 22 and an output of 4. Well, the market's willing to consume 22, or if there are 4 units produced, the market is willing to purchase those 4 units at a price of 24. In fact, it's willing to pay 36, but it'll certainly be willing to pay 24. So all of this, the market is willing to consume at every price quantity point on the leader's residual demand curve. They're willing to purchase along that demand curve, and so because of that, again, the leading firm can act as a monopolist along that curve. And since they can, there's a residual marginal revenue curve associated with this residual demand curve. So there's a residual marginal revenue curve that's going to come off here, and that's going to tell us, there's the residual marginal revenue curve right there, and that's going to tell us that at a price of, at half the market, at half the market, remember we get half the market again, and for the same reason, if you did the calculus, if you took this as your demand curve, and you calculated, you use calculus to calculate the optimal outcome, the profit maximizing outcome of the firm, you would get a price of 10 and an output of 20. So price of 10 and an output of 20. Right there. So the total output of the the total output of the leader firm would be 20 and at a price of 10. So the leader says, okay, I'll produce 20 units and I'll sell the good for 10, and I can act as a monopolist because I'll earn, my marginal cost is 0, while I'll earn all of that as profits. Now we've said that the follower firms follow the lead of the leader firm. That is, they copy the price set by the leader firm. They set their own price of the good, px equals to 10. They say, well, we'll sell our good for 10 also. Well, how much can they sell for 10? Well, the total market demand, because this does represent the total market demand of the market. This is what the market is willing to pay. Well, if the price is 10, the total market is willing. The total demand of the market is 30. So the total, when we go to the demand curve here, it's 30. The residual demand curve says that the leader firm has a monopoly pricing power by selling 20 units at a price of 10. Then the remainder of the market is 10. 30 minus 20 is 10. So the follower firms sell their good at a price of 10, and it's there. They're at a price of 10, and they're willing to sell 10 units. Willing to sell 10 units of the good. They earn 0 marginal. You can see here they're going to earn 0 marginal. Zero profit. So they earn 0 economic profit. I think I said earlier that they earn positive, but actually the outcome of this market model is that they earn 0 profit. So they take the rest of the market. So the total production of the good is 30. So the total output is 30 at a price of 10. The leading firm takes 2/3 of the market, 20 units, that's 2/3 of the market. The follower firms take 1/3 of the market. And at this point G, which is on the market demand curve. So as I say, the marginal cost is 10. The price is 10, so they would earn 0 profit. So they don't earn above normal profit. In this, they do earn 0 profit, just as if they're perfectly competitive. So they're producing 10 units. They earn 0 profit, but they're willing to enter the market at that price. The leader firm earns a profit of 20 in this model. Now, I also want to make just a brief discussion on the cooperation or collusion model. These are, when I talked about the sample of industries earlier in the previous lecture, it suggests that relatively few industries in Japan have a dominant firm, and I think that's very interesting. There's not many industries, and that's one of the assumptions that people make, especially Westerners, about the Japanese market, is that the Japanese firms tend to dominate their market and there's not a lot of competition. Well, that's not true at all. They're very competitive. They're very competitive And very few industries have a dominant firm. So we suspect that the price leadership model may not be particularly applicable to most Japanese industries. They usually have two or more leading firms holding approximately the same market share. You saw that. So the Chamberlain duopoly model may be applicable to those industries with two dominant firms. And the example, remember, the air travel industry, the inkjet industry were two examples. The Chamberlain duopoly model is a non-cooperative game. We can see that there actually have been, traditionally there has been a lot of cooperation in the Japanese market. And this is called collusion, or at least it's termed collusion in many Western countries. In Japan, it's called cooperation. In the West, it's often called a collusion. And such agreements, and this is especially for example, in the construction industry, it's called dango. The literal meaning is meeting and discussing. It's not it's a less common practice than it used to be, but it does exist. It's very. I just want to make the point that it's very difficult to model such behavior, cooperative behavior along the lines that we've discussed in this class. Very, very complicated model. I'll just say that in game theory, cooperative game theory models are very complicated. The model here is, we've discussed about models that are non-cooperative games. So the models we've talked about here are non-cooperative games. They do give us outcomes that look like something that we see in the real world, but remember that there may be more cooperation, that in the real world there also may be some, the firms may cooperate, and this may to some degree is the case in this country. So we'll keep that in mind. Now we're going to move away from that, and I'll take the last about 15 minutes of the lecture. We're down to about 15 minutes, and I'll talk about externalities. We'll talk about externalities. And before I go into that, I'll go over this in the class. Especially I'll go over the leadership model in class at the beginning of class. I just want to make sure that you understand these models, understand what's going on here. It's a little bit complicated. It's a little bit more complicated than the kind of models that you've seen earlier. So I'll want you to try to understand those, because they do model real behavior of firms in real markets. So now we're going to talk. Now we're going to move to talk about and introduce the role of government in the market. So we haven't talked about government yet. We've been talking as if government. We've talked a little bit. I'll take that back. We have talked a bit. We've talked about how the impact that the government can have, either granting monopolies, as is the case with patents, granting of monopolies, or of governments running monopolies. Governments running monopolies, and that's the case in for the petroleum. Much of the petroleum industry in the world are government monopolies. But now we're going to look at how governments, through the ability to tax and regulate, affect the behavior of firms that supply goods in output markets. So we're going to introduce that, and here we're going to put government right in the middle. As a go-between, and what this means is that the governments can intervene directly to firms. They can intervene. The arrows mean the government intervene in output markets. The government intervene in households. They can do that through taxing. They can intervene through input markets, again through tax regulations, that type of thing. So the government can play an important role. Government may play a positive or a negative role. That's an important thing to keep in mind. But we're going to now begin to look at the the various ways that government can play a role in markets. And we're going to do that by first talking about externalities. Because externalities are, and government regulation and the impacts that happen because of externalities, that governments can be an important player in markets. We discussed externalities to some extent, and our discussion of externalities was focused on positive externalities last semester. That is, beneficial externalities that are beneficial to firms. Such externalities included natural resource, we talked about natural resource, and transportation-based externalities. Agglomeration externalities, that is, externalities from firms clustering together. And remember, we talked about network externalities, especially those from telecommunication networks. So our discussion last semester only briefly touched on negative externalities such as pollutions. Now here we're going to turn our attention to negative externalities. And negative externalities are externalities that impose costs rather than benefits. Let's go over this in review. An externality is a cost imposed or a benefit created by an economic agent when producing or consuming a good on households or firms not involved in producing or consuming the good. So it's a cost imposed or benefit created when an economic agent, producer, or consumes a good on household or firms not involved in producing or consuming that good. That's an externality. An economic agent is some household or firm involved in the production or consumption of a good. Very simply, the important point here is that an externality is present when a household or firm with no involvement in the production or consumption of some good by an economic agent nonetheless experiences some benefit or cost brought by the actions of that agent. And an example that you can see every day in this country is covered walkways. A covered walkway is a really great example, and it's one that you can that you can go out, and almost in every neighborhood has some covered walkways in shopping districts throughout Japan. The Shotengai. So throughout Shotengai, shopping districts in Japan, many of them are covered. And you can find them in Tokyo in many locations, or in many other cities in Japan. You can find these types of features, especially if you're from other places in Japan. You might even be more used to that than what you may see in Tokyo. So such walkways provide protection from rain and sun, while more elaborate walkways provide full protection from the elements and create an atmosphere unlike that found in American Mall. Now, they're usually constructed and maintained by an organization of the building owners that are operating along the shopping street. It could be provided by government as well, but the important point here is that when you walk in such places, for the customer, it's an externality. It's a benefit. For example, here, this is taken from Akita. I've never been to Akita in the winter, and I don't know if I would ever want to. I have been there at other times of the year, but it snows a lot in Akita. And here's a shopping district in Akita, and you can see all of this snow. You've got a covered walkway there. It would be if you can walk and stay away from the elements as a result of that. There's no you don't have to pay. You don't have to pay for that, and you get a benefit. If you're a pedestrian walking down the street, you pay nothing for it, but you get a benefit. So that's an externality. And if it's a heavy rain or snow, you definitely appreciate having that. Here's an example in Takamatsu City, and this is one that you can find many places. This kind of covered, where it's completely covered or almost completely covered. In this case, there's a covering, and you can walk down this Shotengai there, and that's an example in Takamatsu City. But you'll see this many places in Japan. Here's an example from Kyoto. There's an example from Kyoto. Now these structures are usually provided by the private sector, and here's the people that are experiencing externalities. These people walking here, they're experiencing an externality. It's a positive externality from that. Now we're going to look at an imaginative story of a negative externality. I like to show you pictures from my neighborhood. This is a building called the Kiyosuryo building in my neighborhood, Kiyosumi Shirakawa. It's actually quite a famous building if you're interested in architecture. And ask anybody if you know any students that are studying architecture or interested in architecture and design. They probably know this building. It's quite well known. This is a famous building constructed in 1933. It's constructed in what's called the it's a Bauhaus example of Bauhaus architecture style from Germany that was very common in the 1920s and early 1930s. At any rate, and if you ever want to come to the neighborhood and you're interested in architecture, well, come and see it. But here in the first floor, now in fact. This is a bar. The bar is not there anymore. When I gave this lecture last year, the bar was still there, and it was very well known to serious dart players throughout Tokyo. If you were a serious dart player, and especially if you lived on the east side of Tokyo, the Wise Bar. The Wise Bar was a very well-known tavern, and very much a tavern. It was a drinking place, not really a restaurant, definitely a drinking place. And I remember that when I would go into that bar on Fridays and Saturdays until about the 2200 hour, 10 p.m. in the evening, business was very slow. And in fact, as we can see, as what happened, this bar is closed down. It just didn't get enough business in the early evening, and it couldn't stay in business. So what we're going to imagine, and in fact, this is what the bar owner may have wanted to do. The bar owner may have wanted to do something to increase business between, say, 6 p.m. and 10 p.m. And let's say that they decided that they wanted to bring live music into the bar, and they wanted to say the slow business hours on Friday and Saturday between 6 p.m. People are willing to go out to drink, and 10 p.m. 2200 on Fridays and Saturdays. But let's say this bar wanted to do that, and let's say that they brought some heavy metal punk band making a lot of noise. Let's say it was very successful. The problem is that next door, and this business is there, the Garage Lounge and Exhibit. It's a small cafe and art performance club that was once a garage in the building. You can see the building has, in fact, there's garages there. I think those garages are still there. There is the Garage Lounge and Exhibit. And they're typically hold performances on Friday and Saturday evenings. So let's imagine that they're having their performances. Here's a performance there, and imagine that it's disrupted by the loud music, and let's say it disrupts here, and it also disrupts the people. This is housing. It's dormitory housing. So this is dormitory housing. Let's say that there are students that are trying to study, people that are going to the lounge exhibit. This would be what the economists call negative externalities. So the owners and customers of the Garage Lounge gain nothing from the loud music playing next door, and yet the noise is dramatically reducing the enjoyment they get out of being at the garage. So many of the building tenants, especially those tenants living directly above the bar, are unhappy with the situation. So let's say that the owners of the Garage Lounge and Exhibit and the tenants most affected by the noise complain to the bar owners as well as the building owners. So let's imagine that the bar owners, their lease requires the bar owners not cause problems for the neighbors, which is very likely. Let's say that the bar owners really need the extra revenue, which probably was in fact reality, since the bar did in fact close. So what can the owners do? What can the bar owners do in order to reduce the negative externality that they're creating? So the loud noise bothers the tenants in the building and bothers the people at the garage lounge next door. That's a negative externality. Those people are not benefiting. They're not attending the music. They may not even want to listen to the music, but they're negatively affected by it. That's called the negative externality. So what we have here are the things that the bar owners can do. The bar owners then would need, in order to keep their neighbors happy, need to reduce or eliminate the next negative externality. So they'll want to reduce, they'll still want to have the music play, and yet, we're running out of time. So what I'll want to do is I'm going to go over this at the beginning of the lecture, the next lecture. We have just a little bit more here. I'm going to begin the next lecture by discussing that. So we'll go over that. But I want you to, I'll send this along. Please go over this. I'm going to make some changes, a few changes to the lecture notes that I've presented to you here. But please go over this. This externality section. So we'll talk about, we'll introduce this topic. In fact, what we'll begin is by talking about externalities and the potential role of government. So, basically what we have is eventually that government may need to step in to create regulations in order to control to control the effect of that. So that's where we're going to stop. We're going to stop here. So I want you to look over this section, and this section I'm showing you right there. I'm going to send you these lecture notes a little bit later in the day today. So I'll send that to you. We'll go over these oligopoly models. I'll just talk briefly about that at the beginning of the next lecture. It's a bit complicated. I want you to understand them the best you can. I can understand it won't be easy at first to understand these models, but I want to get you to understand how these models work and produce the outcome that they produce. I won't have any assignment on this week. I'll save that for next week. I'll definitely have an assignment on this lecture next week. So we'll go over that next week. But so you will need to you'll want to study this and begin to understand this section. So and I will make a few changes here. So I'll close the lecture with that. I'll upload this to my YouTube channel. I'm going to make some changes here on this lecture notes, and I will send that to you later today. So thank you very much, and we will see you. And again, my apologies for missing the lecture yesterday. We'll see you next week, and I am feeling better. Thank you for the nice notes that you've sent to me. I appreciate that from all of the students that send me get well notes. I'm very, very appreciative of that. I look forward to seeing you in class the next time at the regularly scheduled time, and we won't have to have a makeup class, so we won't worry about that. But please view this lecture. Definitely spend the time to view this lecture before the next lecture. So definitely view this lecture before the next lecture. Thank you very much, and we'll see you next Thursday. Bye.